Good evening, everybody, and welcome to the July edition of IndiePie. I am Laura Stevens, an IndiePie co-host, and I'm filling in for Calvin Hendricks Parker, who is on vacation and at EuroPython this week. So thanks to everybody for being here and helping us celebrate 15 years of IndiePie. We are celebrating our 15th anniversary all year long. In May, IndiePie officially turned 15, so we'll continue celebrating 15 years until April of 2023. Make sure that you're registered on Meetingplace.io to receive event reminders and updates, and also to be eligible for awesome prizes. We're giving away 2 PyCharm licenses and a Adafruit clue from JFrog this evening. So make sure to stay on throughout the entire conference or presentation, and we will give away the prizes at the end to people in attendance. And as I mentioned earlier, we're super excited to be hosting quarterly in-person meetings. So we'll have our next in-person gathering in the next month or two. Make sure, again, to register on Meetingplace.io, and you will receive all the updates about locations, speakers, topics, all of the things. So also, in terms of Twitter, IndiePie will be live tweeting tonight. So make sure to follow IndiePie on Twitter, use hashtag IndiePie to share your thoughts with us and follow along in the conversation. We'd like to thank 6 Feet Up, who organizes IndiePie. 6 Feet Up is a Python and cloud expert consulting company that helps tech leaders build apps faster, innovate with AI ML, simplify big data, and leverage cloud technology. Using modern technologies and processes, we make anything possible for our clients. We would also really like to thank JetBrains, who is our platinum sponsor. They have been supporting IndiePie for many, many years, and we are super grateful for them. We'd also like to thank our bronze sponsors, Refi Health. Refi is looking for developers at all levels, so make sure to visit refihealth.com/careers for more information about their hiring, as well as JFrog, who is our bronze sponsor, and will also be giving away an Adafruit clue at the conclusion of the event. If you are interested in becoming an IndiePie sponsor, please email me, Laura at 6feetup.com, and I would be happy to give you information about how you can be an IndiePie sponsor. Also, please definitely join us if you are not already in Slack, the IndiePie Slack. Please join us in Slack. It's a great place to get the latest information when we have speaker changes like we did tonight. We'll post all that information there. It's also a great place to share jobs if you're hiring, and just keep in touch with your fellow IndiePie folks when we are not meeting. And if you have not already, we are officially on Meetingplace.io. We have moved from Meetup to Meetingplace. So make sure if you are still on meetup.com to go to meetingplace.io, IndiePie, to claim your profile. And all that said, that is all that you'll hear from me. And on to the real star of the show, Mason. Thank you so much for being here. And I'm sorry Laura is feeling under the weather, but we cannot wait to have her speak at a future event. And yeah, without further ado, please take it away.
So for those of you that don't know me, which is probably everybody, because it's me. My name is Mason Egger. I am the lead developer advocate at a company called Gretel AI, which we'll talk about later, but we're a company that does synthetic data as a product, has some open source models you can use to generate synthetic data. But tonight we're going to just talk about what is synthetic data, because until I had joined Gretel AI, I had no idea what synthetic data was or the problems that it solved. So without any further ado, let's go ahead and get into it. And if you like my I can't believe it's not real data parody of I can't believe it's not real butter, then you're going to love the jokes, because that's the tier, like that's the bar we're setting for the jokes. So hold on to your hats, because it's going to be a lot of dad jokes. Okay. Of course, whenever I say that, things don't click. We're going to click. So imagine, you're a developer at a company, maybe Working on a web application, let's say Django, because I'm a Django fan. We can get into that argument after the thing. And you're working on building a piece of software that manages students in a classroom. I love edutech. I think it's a really fun sector, but like maybe you're trying to like manage student grades, or you're trying to upload online coursework so students can do stuff. And now that you've been building all of this stuff, it's time to test. But you actually want to test with like real data. You don't want to test with your fixtures. You actually want to see how this performs in the wild. But you are not allowed access to the production database for security reasons. FERPA data is a data that is protected by law, so I can't just willy-nilly access student data whenever I want. That leads to all sorts of things where the government gets angry at you, and you don't want to have to deal with that. So now, instead of actually having access to the production database, I'm going to have to test with maybe some of my fixtures or something that a small data set that I've created that may or may not be representative. And basically what could happen is an edge case slips through, because again, I didn't think about this whenever I was writing putting the three fields in that I need, because let's be honest, nobody sits there when they're testing their apps and creates a whole large testing database. You get away with the bare minimum. So just, this is a problem that developers can face. Another scenario, maybe you're not a web developer, maybe you're a data scientist or doing some sort of machine learning, and you're trying to build a model. And you figured out what you want to do. You want to say, predict a rare disease, based on some patient data. So you start looking for relevant data sets, but you find out there's just not enough data on this one rare disease. This rare disease either doesn't show up, or there's not a lot of data that you have access to. So you have to train your model on what you can get your hands on, which could be few and far between on data. And then the model is just wildly inaccurate and unsuccessful because the size of the data that you were training it on was just not adequate to actually be representative of the disease that you're trying to do. But wait, someone comes to help you, but they're in another hospital down the road, and they have the data set that you're looking for, and they want to give it to you so you can build this model, and you hit the brick wall because it has PII information in it, personally identifiable information in the data set, which means that you're going to have to go through 9 months of lawyers to get to it, and you're probably not even going to get to the data anyway. You're not allowed to access this data. And then these are very common data challenges that developers deal with. So the ability to access usable testing data, whether it's for web development or machine learning, 35% of all data science time is spent in this data gathering stage. It's one of the largest stages that we have for getting data. Data is very often completely inaccessible due to the personally identifiable information. Another issue that we saw in our example was there's limited data sets. Lack of quality data can affect model training results. It could be prohibitively expensive or actually impossible to collect more data. So you're just stuck. You want to do something, you don't have the data to support what you're trying to do. And then we get into the land of biased data. Data sets can often be skewed, and very often are skewed towards representation of subjects that may not be indicative of the whole. And honestly, let's be honest, biased data more often than not causes harm. So there could be harm in these data sets, whether intentional or unintentional. And now your model or your testing data is not that great. So what do we do to solve these problems? And one of the solutions to this is synthetic data. So let's just talk about what is synthetic data first. The really fancy high-level Webster's dictionary definition, this actually comes from the Gretel CPO, but it sounds so formal, I say it should be in the dictionary. Synthetic data is artificially annotated information that is generated by computer algorithms or simulations commonly used as an alternative to real-world data. So you may hear that, and you may go, well, isn't that just fake data? That's the first question that everybody asks me. The answer is not really. Synthetic data is different from fake or mock data. You may be thinking of faker in your head. These are all the questions that I had when I interviewed for Gretel. Fake or mock data may not be representative. So whenever you create synthetic data, you're creating it off of an existing data set. So your fake data is just not representative. Like asking dev-urandom to give me a representative data set is about as fun as going to Vegas. It's fun, but you're not going to actually win. Fake or mock data can often be too clean. This is a really funny one, because sometimes people we tested, we have all these fake data. It's yes, but faker always gives you exactly what you want all the time. Does the customer always give you exactly what you want all the time? The answer in that is very rarely not, and more often than not, never. Synthetic data is actually generated from existing data. So it will look and behave like the initial data set. So when you create synthetic data, you're creating it with basically a seed of data, and you are creating something that is representative. So synthetic data can be nearly as representative as the initial data sets that you have. So it is not just fake data. Fake data is completely random without representation. Synthetic data is a little bit more involved, but it allows you to create this level of representation. So let's talk about some of the benefits of synthetic data. There's a lot of benefits to synthetic data. I'm going to cover what I consider the big three. There's three big ones that I like to cover. Synthetic data allows us to make private data accessible and safely shareable. Synthetic data allows us to generate more samples when we have limited data sets. And synthetic data allows us to reduce bias in machine learning data sets. And we're going to go over these a little bit more in depth. So making private data accessible and shareable. This is a big one, and this is probably one of the biggest ones. The other two are great. This is like the star. Data very often contains PII, which is personally identifiable information. If anyone here knows anything about GDPR or FERPA or HIPAA or COPPA or any of these acronyms that are meant to protect your data, as they rightly should, these create headaches whenever you're trying to actually work with data in the field. The data is very well protected. It's very risky, security wise, and in some places even illegal for developers to be able to have access to this data. And let's be 100% honest. Developers and data scientists do not want access to PII. This just creates headaches for us. Like now I'm suddenly responsible for everybody who's ever used my product's credit card number. No, I don't want that hot potato. Do not throw it at me. So developers don't care if the data is actual real data or if it looks like real data. So generating synthetic data allows us to create a statistically similar data set while removing all the PII. This will allow us to share the data not only within the company, but externally as well. So when we create this synthetic data, what we do is we can feed it the production database. This production database will train a machine learning model, and then this model will generate data that and Gretel has some tools on, qualitating the score, but we'll have these similar relationships as the initial data set. So the data then becomes completely shareable because all of the people's information in the data is completely fake, or quote unquote fake. It's not real. If it gets leaked, it isn't hurting anybody, but it still shows the correlations that we want from our data. Also, if at any point, we think we said this, I'm watching the chat. I'm trying to watch the chat. If at any point you have any questions, please drop them in the chat and I will answer them. You can ask them now. And I like doing live chats because my brain's on that track. And if you ask while I'm on that track, you may get a better answer than if you ask me 20 minutes from now when I have left that station. So feel free to drop some stuff in the chat. If you have any questions, I'll happily answer them now, or you can wait till the end. So number 2. Augmenting small data sets. So another big issue that developers and data scientists alike, is not having enough of the right data is a serious bottleneck. Data is often the most valuable asset within a company, and collecting data is extremely expensive and extremely difficult to do depending on the data that you're trying to collect. Now, if it comes to user login information stuff, not too terrible. If you're trying to get registration information or stuff that you have to pull the data for, could literally be like pulling teeth. It might actually be easier to track down the developer or the person and pull the teeth than it would be to get the data. Like I said, these are the jokes. I'm looking for laughs in the faces. So you don't have to, I'm lying. But it's very difficult to gather data. That is true. It is true now. It will be true forever. It should remain true, because if it ever gets too easy to gather data, that means they just own us. And then we have a whole nother problem in and of itself. So synthetic data allows you to generate an unlimited amount of data based on a relatively small data set. So what you can do with synthetic data is, say you have this small data set of, say, I don't know how far we've tested the limits of how much it actually is, but I would say within the range of a couple hundred to a couple thousand records, but you need a much larger data set. You can take this and then just generate more data that is representative of that small data set. Now, a lot of people will ask, well, what if that small data set is unrepresentative? Yes, that will be a problem. So if that small data set is completely skewed in one direction, you will get completely large quantities of completely skewed data. But more often than not, it's better than nothing. And really and truly, sometimes this data isn't as skewed as you think it is. So if you think the data set is representative, but you just don't have enough of it, you can generate more of it to augment it. That really helps when you're training your models because the model has more data to look at. This is especially prevalent in the public sector because the public sector has had really poor data practices, such as storing data in like PDFs and stuff, or completely unreadable formats that cause for an abundance of inaccessible data. So being able to augment data sets and create more is a very valuable thing for a lot of developers. And then finally, one of the things that synthetic data can help you do is it can help you reduce bias in your data sets. So biased data is a very big problem. I'm sure every now and then you'll see something on Hacker News or something in the news of this AI model did something terrible because they did something terrible with the data. Like this is not, I see this once every couple of months. This is not uncommon. So biased data leads to inaccurate models, unfair results, and may even cause harm. So we have to be really careful about how we're using data. And if the data is biased, we need to be able to somehow solve for this. Again, collecting more data is hard, so it gets really difficult. If you can identify the bias in your data set, you can use synthetic data to balance your data set. So we actually have a really cool case study about this where we were using synthetic data. They were able to take a data set of heart disease prediction models, a data set that fed heart disease prediction models, where the data set was 68% male data and then 32% female data. So the ratio was pretty much a 2-to-1 ratio, which meant that the model was not that great at predicting whenever a female would potentially have a heart attack. So what they were able to do is use synthetic data to generate more female patients, to de-skewer it. So they were able to take the seed of the female data and then just augment it enough to where the split became 50-50% on the ratio. And incredibly enough, whenever they did this, you were able to increase the accuracy of the heart disease prediction model from 88.5% all the way up to 96.7%. So 6.17% more females could now be more accurately diagnosed with heart disease because we were able to identify the bias and then use synthetic data. Now, I will admit this is more of an advanced use case. It's not actually that difficult to do when you're using synthetic data, but being able to identify biases in your data sets, that's where the difficulty is going to come in. So if you can identify it, you've already done the hard work. Now you can just use synthetic data to do this. So yeah, another question that I get out of that is synthetic data accurate? How do we know this data is accurate? Well, unlike fake data, synthetic data is nearly as accurate as the real data that we have. In some cases, we've actually seen an improvement in accuracy using that. I don't know how that dark magic works. It's in that case study. I'm still at the point where this seems like magic to me, which is a fun place to be when you're in tech, because eventually you learn how everything works and nothing's magic anymore. And you don't get that sense of wonder. But I get this sense of wonder when I work with synthetic data. So it's a lot of fun to do. Augmenting a training set with synthetic data from all of the tests that we have done had a mean machine learning accuracy of less than 1% from their real world equivalents. So the data accuracy is there. Like, it's really, really cool. So where do we see synthetic data in action? Is it being used in the wild already? And the answer to that is yes. We see it everywhere. We're seeing it in automotive and robotics. If anyone y'all, this is IndiePie, so you're not in the Bay Area, but you may be, who knows? But I know Cruise Technologies, which does self-driving cars, a lot of synthetic data is used to generate conditions for self-driving cars. So we're seeing this a lot in automotive and robotics. Financial services, by creating synthetic time series data to enable sharing that doesn't compromise customers' privacy. Excuse me. Cybersecurity and InfoSec, using synthetic data to train machine learning models to better detect rare events, including fraud and cyber attacks. Healthcare and life sciences, this is the fun one that we're working on right now. And we've got a cool case study. We're actually synthesizing genomes right now. So we are synthesizing a human genome for detection of some disease with Illumina. So we're being able to synthesize all of that and create, medical breakthroughs and stuff that wouldn't have been possible. If you've ever thought that the DMV gives you red tape, try to go get your hands on a genome. It's actually very difficult, and it takes months, if not years, and you have to sign more forms with more governments than the law allows. If you can just synthesize your own genomes, then it's easy. Everyone just gets everyone gets a genome, which I think is hilarious because we all have a lot of genomes, but apparently getting a hold of one is difficult. Anyway, that's a joke that makes me laugh. It doesn't have to make you laugh. So manufacturing synthetic data to simulate complex supply chain issues and more. Like, the list goes on and on. The synthetic data really is starting to skyrocket. And I realize now that this is the short version of my slides, which is why I have slides missing. So this is what happens. So how can you get started using synthetic data? Well, there's many resources available. There's a really great link here, and I need to update this again. I'm going to make myself some notes on my little pen, update slides. But there's a really cool thing, like on Open Source Agenda, you can find all the open source projects related to synthetic data. I work for Gretel, so you're going to now get to hear about that part. Gretel makes it really easy, or easier than it's ever been. I found there's not really much easy about machine learning and data science. All of the models that Gretel uses are open source. So if you want to be able to just download this model, fire up a machine with a couple of GPUs and train a synthetic data model on your PC, hey, I have the link later in the notes. You'll totally be able to go and grab a GitHub repository and do that. There are no code options. This is more with just Gretel itself, and you can run it in the cloud or on-prem. Again, data privacy laws make this fun. So the open source library is called gretel-synthetics. There's a link in here somewhere. There are multiple models right now. There's the original synthetic model, which is an LSTM model. We have our own version of GPT-3, which is pretty fun. I use it to generate cocktail recipes because I'm the kind of person that just messes around with GPT for fun and doesn't do anything actually valuable with it. You can train the synthetic data models yourself, so you can totally go into our Gretel Synthetics repository and download these models. You're gonna need a GPU. Don't melt your silicon, use a GPU. If you're doing it in Google Colab, make sure you select the option to accelerate with GPU. It's at github.com/gretelai gretel-synthetics. There's also synthetic docs. Our docs are there too. Really cool library you can use to do that. Or you can do, what I do every day, which is use our cloud offering. If you don't have a GPU, or you just want to try it out for like 5 minutes, there's totally a free tier. Many ways to run a dashboard with node code. There's a CLI. There's a Python SDK, which I tend to use more often than not. That's typically what I use. There's a REST API, a couple of additional resources here. Docs.gretelai, github.com, our blueprints. So our blueprints so if you want to test this out, we actually have like completely running working examples with data sets. If you wanted to test this out right now when we're done with this meetup, I would go to the Gretel blueprints one, because you'll be able to see real production, examples. If you want to be silly, you can go to the Fun with Synthetic Data. That's the repository that I maintain, that I'm currently doing, and that's the one where I have what I call Gretel Bartender, and I feed it like 8,000 different recipes for cocktails, and then we see what GPT spits out. Some of them actually sound pretty good. Some of them kind of hilarious how bad English, how difficult the English language can be sometimes. Drink at your own peril. And if anybody wants any swag, I have these stickers available. If you want to, this slide deck was for my presentation that I'm doing at Pi Ohio, which is happening at the end of this month. I already recorded that video, so I didn't want to just fill out this form. It's the same form. If you want any of these stickers, fill out the form, give me your email address, and then put your shipping address in there, and I will ship you some Gretel stickers and some synthetic data stickers. Yeah, 6:33. Wow, I got through that quick. Yeah. I'm gonna have to make this presentation a little bit longer. That's all I actually have. Oh, I guess you can follow me at Mason Egger for Twitter. You can follow Gretel and like all the stuff that we're doing on Twitter too at Gretel AI. You can get started with it. All these slides are on my website. I have, okay, there's a slide missing that I wanted to talk about, but I'm trying to remember what it says. Oh, okay. So according to the Gartner reports, synthetic data is going to overtake real world data and machine learning application models by like 2025. So like the synthetic data is very much on the rise. Let me see if I can find that. It's in our blog somewhere. If you're down for some wild browsing, I'll just browse the internet. Actually, this is our blog, and then my favorite blog really is this. That's not it. What is oh, maybe we finally released enough that it got bumped to page 2. This what is synthetic data page. This page is also 100. If you want like the text version, I'll drop this in the chat. If you want the text version of my talk, like 95% of my data came from this blog from our CPO. Yeah, this is it right here. 2030. Sorry, I was a little bit ahead of my schedule. So by 2030, synthetic data will basically completely overshadow real data and AI models. The tech is just getting better and better every day. So it's really cool. Yeah, what questions do you have? I have a couple things that I could talk about more in depth. I can also, since we've got some time, let me pull up a Jupyter notebook and we can just train a model real quick. And I can just show you how this works. But yes, if you have any questions, feel free to either unmute or drop something in the chat. Happy to chat with you. And we're going to be training a couple of models, so this will take a minute. So we're going to be sitting here in awkward silence unless somebody asks me a question. So.
Well, David.
Hi, good afternoon. I have a question. How can we guarantee that the synthetic data we are generating matches real life data? Okay,
so let me find that on the, yes, that's a good question. So synthetic quality score. I'm taking notes for myself because I'm realizing that like I said, this is a in progress talk. So Gretel itself provides what we call a synthetic quality score. So where do I go to talk about that? I have to find out where that's at. Is it in the other blog? It's in the console, but like I want to find like the actual documentation on the quality score. I think we have some. Okay, so this part of the blog actually talks about how accurate the synthetic data versus the real world data is. And we provide, so it has like all these models, but we provide a Gretel synthetic report. Right now, this is limited solely to the cloud product, but we are very close to releasing the open source version of this. So you'd still have to use, like, basically you would sign up for a Gretel account and you could then compare 2 data sets and it would do, I think it's like 6 different tests they do. Principal component analysis, deep structure stability, field correlation stability, field distribution stability, and it will provide you with a score of like how far, not only how far is the synthetic data drifted, but what is the privacy involved. So the other thing that Gretel does that we haven't really talked about in a while is Gretel started off as like more of like a data privacy company, and that was kind of pivoted more into like the synthetic data was part of it, but we wanted like to talk more about synthetic data than the privacy aspect. But you can use things like differential security, I think. What's it called? Differential privacy. I don't know why that word was escaping me. There are features with differential privacy and different levers you can tune within Gretel to not only make the data, more closely resemblant of the original data set, which you will soon be able to use a REST API to say, or how close are these 2 data sets? But you can also use it to ensure, and I wish these screenshots were a little bit bigger, the privacy filter of it. So outlier filtering, similarity filtering, overfitting, differential privacy. So like how you want to make sure that your data is private and accurate. So as of right now, this exists in the Gretel Cloud. I'm literally testing the open source library version of this like right now. So it will be out hopefully within a couple of weeks. So yes, we have tooling to be able to tell.
It seems like a very complete analysis of the data.
Yes, it is. I wish I could speak more to this. I used to be in DevOps for a very long time, and I've suddenly moved into data science and machine learning. So ask me in a year, and I'll know so much more about this. But I've been here for 3 months, and I'm still like learning like how neural nets work and stuff. So you caught me at a really early time. This is hilarious because like every time I switch jobs as an advocate, it's the same thing. Like, don't like when I first started at DigitalOcean, I was like, don't ask me too many questions. I don't know too much, but I'm learning about it now. So in a year, I'll come back. I'll have a whole lot more to tell you about it. But this blog that I dropped in the chat really is like just the perfect thing. It explains the entire process. So yes, we do a really good job with that, and I'm really happy about that. So let me go ahead and log into my Gretel. Okay, so the way that Gretel works is you basically would like you create an account, you get an API key, and then what we're gonna do is we're gonna generate some of these cocktail recipes. So there's a Gretel client. There's also a CLI client you can use. The pricing model has a pretty generous free tier, so you can totally run this model and train it and not even have to worry about it. You could probably train like 3 or 4 models a month before you start having to worry about paying small amounts of money to train them. But we're going to go ahead and just run this while we're here, do a little bit of live code demo. So all we're doing right now is pip installing the Gretel client inside of Google Colab. Was another new thing. When I left DevOps space, I stopped using Vim and moved to Google Colab, and that was a culture shock. I guess I could still technically write notebooks in Vim, but it sounds difficult. So, okay. And then we have just a whole bunch of imports and such. We have like our session, our poller, basically the projects that get creating a project, getting the project, setting some pandas options. And then we just give it our API key, ask it to configure a session, it logs us in. And then this is like just a default, like whenever you go to create a project, you'll be given like in the console, you'll be given a default schema. Again, you can change these, batch size, how much relevance in between them, epochs, how many times you want the model to actually go over the entire data set, weight decay, learning rate, all of these things. So basically, you just create this configuration file. We give this to you in the docs. The default one does pretty good. And then we're just going to load this specific data set from S3, which is just like a drink data set. So we have, this is called the brain teaser, 30 milliliters of white. I don't know. I don't drink. I don't know what half of this stuff is. Porto flip, just all of them, about 500 rows of synthetic cocktail recipes. So we load it in, basically just create like a little training to data CSV that we can send it over with. And then now we will just basically send it over. We create a model object, and then basically send our model configuration, which we defined up here. Create or get new unique project. So you're basically going to just create a new project. And what this does is like, we have a preset model. So there's a preset model, and this is just a GPT model. And then what we do is we train the model that we have on your data set and then use that to generate it. So we've already done a lot of the original training, and now we're just training it against your data, which this usually with 3 epochs and such, this will but only 500 records. This will take like 5 to 7 minutes. So now we sit here and have people ask me questions while we wait on the training data. And basically the poller is just going to submit it to Gretel in the back end. And it will build it and run it. Now, you may be asking, I guess a good question to go over this, you may be asking like, well, what if I don't want Gretel to upload all of my data to Gretel? What if I work in a regulated industry, or I just don't want to upload my data to a cloud provider? You don't know who I am. You don't know what I do. Like, I understand that. I think I would like for you to trust me, but you don't have to. Well, there is an on-prem model. Now, the on-prem model still requires a Gretel account, because what it does is the telemetry and the usage time of the APIs and stuff gets fed back, but nothing else. So if you are trying to build this kind of data on your local on-prem, you can use it on-prem and then train it. All your data never leaves your data center. And then you have your synthetic data, and then you send us back, hey, this model took this long. Basically, crash reports and bug reports for us to be able to debug if something cranky happens with the model. And then also usage minutes and stuff, because Gretel does basically charge you like by the compute minute. Different plans have different things, and you can buy extra minutes by the time. So as we can see here, it's now training Training the model. And we're just going to basically wait on it. So
while we wait, another question.
Yes, go ahead.
Is there like a sample notebook I can show my team and tell them, look, this is the kind of stuff we can do with this synthetic data?
Yes, there are. Let me go ahead and just drop some links here in the chat. So the ones that I would say to use are the ones here in the Gretel blueprints. These are production ready blueprints. So while we're waiting, let's just talk about what's in here. So there's our balancing the heart disease data set that I talked about. You can actually run that notebook here and balance the data set. You can do conditional data generation with GPT, classifying free text with natural language processing, credit card DP notebook. I don't know what DP, differential privacy, credit card data differential privacy notebook, some more differential privacy stuff. Where's the one that I really like? Is it in here? We also, another question that I seem to get asked a lot is, do you do time series data? The answer is yes. So if you need to be able to create synthetic time series from like sensors or IoT devices or anything like that, we can do synthetic time series data. Where is it? It's not in here. I'm cranky now.
Yes, I was seeing the time series data in the blog. And
yes,
it's very interesting because sometimes you don't find the kind of data you need to test something.
Yes.
Able to create it can
yes.
take a lot of work.
Yes, so that's one thing that I've talked with a couple of people. I talked with someone before who was doing manufacturing engineering, and they asked, like, you know, using synthetic data to generate events that don't happen very often. He was saying specifically that, like, he works in a factory and they need to be able to test the data on the sensors on the actual machinery of when it's going to fail. But they said that those sensors don't fail every 3 to 5 years. Like, it takes a long time for them to fail. So, like, being able to generate more of the failure mode, so then you can test against it, was something very interesting to them. That's 100% something you can do. That's a little bit more of an advanced case with synthetic data, but you can tell it. You can basically precede the model, say this is the type of thing, or this, I want like this type of data to come out of it, like more or less of this, and you'll get it. And it's really valuable to be able to do that. The one I was looking for here that I can't seem to find is it's in our blog, but creating synthetic data out of table relational databases. Specifically, I think like SQL and SQLite and Postgres. So you can also use this not only with like JSON and CSVs, but also use it with databases as well. Let's check on our model. Is it done? Yes. Okay. Wait, is this the right one? Yeah.
We were on the bartender before.
Yeah. Wait, this might be the wrong one. Actually, the wrong one. This is the original data file. Okay, so we've generated that. Oh, no, we didn't. I'm sorry. I forget how my own product works sometimes. So we've generated synthetic. So let's look at the originals. We've generated some synthetic cocktails. I did this, and this does a different step. So, you know, this is called a blah. It has this. Here's how you use it. And then if we come down here to these synthetic cocktails, is called the Long Island cocktail, 3/4 ounces of vodka, 1/4 ounce of lime juice of ginger ale, add ice and mix into a glass over ice cubes. Remaining ingredients, strain. Pretty good. Now, what we are seeing here is as the model goes longer, it kind of like devolves a little bit, which is something that you have to do when you're training synthetic data. So like right now, we give it like a maximum amount of like, how long do we want this text to be? But with, especially when you're doing GPT training. So like if you're doing something where you're doing synthetic data on like numerical data sets or anything along those lines, like, you know, time series data, those are interesting and they work really, really well. GPT works well too, because I mean, it's pretty good, but the longer it gets, apparently the crankier the model gets. And it's like, serves two. I was like, yeah, we get it. You're good. But GPT, like, these are actually, I'm not going to tell you they're good. I would be very interested if someone were to try one, but we actually were able to generate synthetic. These are all completely synthetic cocktail recipes with using GPT. So someone wants to tell me, I hope there's no two alcohols you can mix together that cause an explosion or like mustard gas or anything, because I wouldn't trust it. And also, like the thing of all good open source, there's a disclaimer that says, don't blame me if it blows up. Limitations and biases. The GPT model is notoriously interesting. It was trained on the whole internet. Does everyone think that, all of the data on the internet is quality? Like, I think it's trained on like all of Wikipedia, all of Reddit, which just sounds like a bad idea when you hear it said out loud.
Yes. When you see it out loud, you say it sounds like a bad idea.
Yeah. I wonder how many people build startups and they never say the idea out loud, and then if they did, they'd be like, oh, that doesn't sound good. So anywho, and then you can do a lot of other really cool stuff with it. You can do conditional data generation, which I just learned today that I've been doing wrong the entire time. So I have to learn how to actually use this prompt thing. Like I said, I'm still learning. I'm new at this. But yeah, that's synthetic data generation.